Hello and welcome to today's webinar, Demystifying the Software-Defined WAN. My name is Kevin Gavin, and I will be your host for today's webinar. I'm Chief Marketing Officer at Talari. Joining me today is John Burke, the CIO and Principal Analyst at Nemertes Research, a leading research firm, and John is a widely recognized expert in wide area networking. Also with me today is Neil Abogado, Director of Product Marketing for Talari. We have a very informative agenda today to help folks understand how they can improve their wide area network. After this brief introduction, we're going to start with John giving an overview of this SD-WAN state of the market, followed by Neil giving a brief overview of Talari Thinking WAN, and then we will give a few real-world customer use case examples of how enterprises are using SD-WAN to improve their WAN performance. And finally, we'll end with an open Q&A where you all can get your questions answered. Because we've got a lot of folks on the call today, all the lines are muted, but feel free to go ahead and type your questions into the chat window, and we will review those questions and make sure we answer them towards the end of the webinar. So thank you very much for joining, and John, over to you.
Thanks very much, Kevin. Thanks for having me here, and it's a real pleasure to get a chance to address everybody on the subject of the software-defined WAN. We'll start by introducing Nemertes, the company that I work for, and then dive into what we see as the current state of the enterprise WAN, not so much the market from the vendor side, but from the demand side, the folks who are using WANs. Then talk a little bit about what IT wants out of its WAN that it doesn't currently have, and how SD-WAN is the set of technologies that tend to provide to IT what it's looking for in a WAN. We'll wrap it up with some recommendations. So for those on the call who are not familiar with Nemertes, we are a research and strategic consulting firm, and we focus our work on analyzing the business impact of the deployment of emerging technologies. And we, as our primary mode of research, engage IT professionals in conversation about what they're deploying and why and how and what's working and what doesn't. We speak to a couple of hundred enterprise IT organizations every year across all verticals on a wide variety of technology subjects. And it really is a conversation, and it really is between us, the analysts at Nemertes, people like me, and folks who are actually getting things done in the enterprise. It's not a phone bank. It's not a multiple choice survey. It's a conversation. And we collect a lot of data, both quantitative and qualitative, and turn that into, well, this kind of presentation, as well as the advice that we provide to our clients. So one of the things that we track over time is the state of the enterprise WAN, and the status quo, really, of what's going on in the enterprise right now. What's typical is this three-tiered WAN, where you've got data centers that are connected to the wide area network via some very high capacity links, typically connected to each other and to the WAN cloud that provides services to the other offices in the organization. You've got an MPLS cloud connecting all the offices together. And in places where you can't get MPLS services or where it is ridiculously expensive to do so, you've got a few sites that are on the internet only. They have some kind of broadband connection, and they have IP VPN set up back into one of the other offices or directly to one of the data centers. This has been the status quo for several years now. We, I think, first identified this maybe in 2006, 2007, when the shift to MPLS was really picking up steam. And what is happening, though, is that this very simple picture of the wide area network, and it's met IT's needs for a long time, it's the enterprise need for a long time, is increasingly not matching up well to what people are trying to accomplish in IT, how they're trying to deliver services. The WAN has to change because how we're delivering IT services has changed so dramatically in the last 5 years. And It's important to note that at this point in time, for any large enterprise especially, services can and pretty much are being delivered from everywhere. They're being delivered from public cloud environments. They're being delivered from external hosted facilities, from co-location facilities, from external private cloud instances. They're being delivered from platform as a service offerings, excuse me, things like Microsoft Azure, and of course they're being delivered via SaaS. Nearly 100% of the companies that we talk to have at least one SaaS application and service. Most have many. The median number is somewhere north of 7, and really for a large corporation is probably north of 20 by now. At the same time that we've been taking more of our services out of our own data centers, things that are directly connected to the WAN, and shifting them off into one or another of the internet-connected services that are out there, whether it's Amazon or Azure or Salesforce or IBM Smart Cloud or Oracle On Demand, you name it, we're delivering an increasing percentage of our services via the internet, then via our WAN, or we're delivering an increasing percentage, an increasingly critical part of our enterprise workload via the internet as we move things that we care more about out into these external service sources. And so a WAN that's built on the premise that the vast majority of your services get provided out of your own data center, and that internet-provided services are a relatively small and relatively less critical piece of the overall portfolio, rapidly fading in the rearview mirror. And the result of this massive change in how we use our WANs has resulted in an enormous amount of complexity on our WANs as we try and overlay different kinds of service delivery strategies and different kinds of optimization technologies on top of what was a fairly straightforward kind of architecture to start with, because we're trying to make different kinds of delivery promises and different kinds of service level agreements on all the different services that we're offering, no matter how we're offering them, no matter where we're sourcing them from. And we're trying to implement increasingly complex security policies on top of this WAN structure. So we want to control more carefully who can access things, how they can access things, when they can access things. And we're trying to provide increasing levels of reliability, because the WAN has only become more important and performance across it more important, and therefore reliability, availability also increasingly important. And at the same time, though, we're still managing our WAN like it's 5 years ago, 6 years ago. We're managing piecemeal an infrastructure that is no longer simple enough to manage piecemeal. It's not good enough to manage routers one by one anymore. And also, we're managing it in a context where the reliability of the baseline services that we're relying on, essentially MPLS, is changing. We at Nemertes, we've been fielding for the last 18 months, 2 years, increasing numbers and frequency of reports from our clients and from the folks we just talked to for research purposes, that their reports that their MPLS services are becoming less reliable, that they are experiencing more outages on their connections and longer outages, that they're experiencing fluctuating loss rates where the packet loss can skyrocket briefly and then go back down to baseline levels, that they're experiencing increasing fluctuation in latencies. The jitter on their links is growing. And also that although MPLS costs for a given amount of bandwidth haven't been going up, they've been going down. They haven't been going down fast enough to make real redundancy at high capacity a truly available option for many of the locations that they have to provide services to. They can only get one link, or they can only get a link from one provider. They can only afford one link, and they can't really afford enough bandwidth on that link. So we're seeing that redundancy is too expensive and reliability is decreasing in this traditional MPLS-based cloud of WAN services. So when you put together the things that we've been experiencing in the enterprise, a lack of performance, the inability to boost performance by adding bandwidth, the lack of reliability, and the increasing challenge of getting really good delivery of packets, without loss, without too much latency or too much variation in the latency, the complexity of changing things in the WAN in order to get from it the behaviors we're trying to get, the fact that the architecture and the implementation of it that we have to wrestle with is really rigid, and something we haven't mentioned yet but that we've been hearing just universal complaints about, the high latency in getting a new location lit up on the MPLS network, the fact that delivery times have crept up and up and up from 45 days to 60 days to 90 days to a promise of 90 days but a delivery on 120. Folks are getting to the point where they can't make a reliable plan about how long it's going to take them to get a new branch office lit up if MPLS is their only option. What we've come to is a point where the WAN is now an incredible inhibitor of agility at the organizational level. It's a very expensive Achilles heel and choke point on delivering services and making rapid changes in how we deliver services. It's hard to do something new quickly, and it's hard to do anything affordably if it's going to require dramatically more bandwidth. And of course, IT wants kind of the opposite of all these things. They want to have more choice in how they connect up locations. If they're having trouble getting reliable delivery of new connections or delivery of new connections in all the places they want them from one provider, they should and want to have options in what provider they can get services from. Likewise, they want to have more options in how they provision the branch offices that they open up. They don't want to be locked into a single provider necessarily on the network hardware side. Likewise, we've seen ongoing stasis in the level of staffing in the WAN. We don't see WAN staffs growing even though we see WANs growing. We don't see WAN staff growing even though we see WANs getting more complicated and more mission critical. So IT needs a WAN that can do more in an automatic way than what it's been working with up to now. It needs more automation. It needs more intelligence that's built into the systems that it's working with, so it doesn't have to exhaust the people who make the WAN work. Likewise, and on the same theme, it needs a WAN that is simple and easy when it comes to deploying a new location and managing the entire wide area network as a unit. Because in addition to needing automation, the IT staff needs simplicity in order to give them the leverage that they need in order to be responsive enough to enterprise needs and demands for change. That agility, of course, comes with intelligence, with simplicity, with choice in providers as well as in technologies, and with with all those things, IT needs to drive the ability to make any kind of new deployment in most cases, needs to be able to show some kind of savings in an all things being equal environment. If we do it this way, we can save money doing what we're doing now. They also need to be able to look forward and say, not only can we save money on what we're doing now, but we can actually afford to do more. We can afford to have more locations. We can afford to have redundant connections at more locations. We can afford to dramatically scale up the amount of bandwidth we've got in any given location. So IT needs all these things in its go-forward solution if it's going to really survive the next 5 to 10 years of rapid evolution in the enterprise environment. What we see evolving is a new status quo where there's still an MPLS network out there for most large organizations, and it's still the core of their connectivity to large offices and from those offices to the data center. But we now see an increasing number of offices that are on MPLS and connected to the internet directly, and a much larger number of offices that are connected only to the internet, not because they're in the middle of nowhere and have no other option, but because it's the best option that's available for them in terms of speed, reliability, and agility at the branch strategy level. And we'll still see remote offices coming in via the internet only. All of this is happening because of really dramatic changes in the availability and the reliability of consumer broadband connectivity to the internet, as well as the development of technologies like the SD-WAN. We focus on SD-WAN and WAN virtualization together. We actually think of WAN virtualization as a subset of SD-WAN technologies. And the really key change that SD-WAN brings to the environment, the really key improvement that it makes at a fundamental technological level, is that it brings virtualization or abstraction to the WAN in two ways. Looking down, it makes a bunch of separate links into a given location look like one pool of bandwidth on which you have some connectivity with different flavors. It might have extremely high availability and reliability. It might have extremely low cost. But the point is the SD-WAN management and the SD-WAN appliances take care of paying attention to all those things, and then turn that into a single pool of bandwidth and abstract upwards as well, and say, what kinds of wide area networks would you like to create? And we will make them happen on top of that available pool of bandwidth. So abstraction in two directions, making a bunch of different links, a bunch of different kinds of connectivity look like a single pool of bandwidth that you can allocate out based on the needs of your different applications, and looking up, the ability to define essentially different WANs for different purposes and have them all coexist on that single pool of bandwidth that's available, so you can mix and match the network topologies that make the most sense to you for performance or make the most sense to you for security reasons, and mix and match the kinds of connectivity that make the most sense in each given location to achieve the kinds of redundancy that you want, or to get the low cost of bandwidth that you need. Another key characteristic of SD-WAN is that you're not doing node-by-node configuration of your wide area network anymore. You're managing the WAN centrally, and the SD-WAN solution is taking care of all the node-by-node reconfiguration that needs to happen. That applies not just to defining who can talk to who, but in defining which applications can be seen from which locations, what path packets for that application will follow through the network. Do they all have to be routed through a data center so they can go through an archiving utility or a DLP utility? Excuse me. And of course, you will again centrally be able to define what kinds of performance characteristics a given class of traffic or given application's traffic needs. Does it need, absolutely 100% packet delivery, even if there's some latency involved or some jitter involved? Is it okay to have packet losses as long as it's high priority delivery of packets? All those kinds of performance characteristics, you should be able to define them, associate them with a class of traffic, and then let the SD-WAN software take care of mapping those requirements onto your available pool of bandwidth. So when we looked at the SD-WAN market this past summer and evaluated a bunch of different solutions, we came up with a set of key characteristics for solutions in this space, starting with how it aggregates that set of links that come into any given location? Does it fully aggregate that? Does it give any given application or any given WAN access to all of the links simultaneously, so it looks like one giant fat pipe? Or does it only partially aggregate, so any given app can get at most the bandwidth available to it on any one of those links? So that's one level of aggregation and packet routing characteristic to pay attention to. Another is the granularity of packet routing, or traffic routing, I should say. Is it going to go at the application level? Is it going to go at the flow level within the application's set of flows? Is it going to go packet by packet and make decisions basically for each packet, what's the best way to get it to where it needs to go next? On the security side, you should be able to have a similar level of granularity, right down to, can I deliver this packet to that location over this link? You should have the ability to encrypt connections between locations, independently of whether or not the application traffic itself is already encrypted. You should be able to link other security services that may be running in your data center, for example, into the traffic flows. So again, if something has to go through the DLP service, then you should be able to loop that in ideally. And you should have a really broad set of characteristics of the traffic that for traffic control or for security control can be acted upon, so-called actionable factors. Not just address, port, protocol, application, but also user and possibly time of day or means of accessing the services. If things have failed over to an internet link, are there things that you're not allowed to do over an internet link, and so you can't do them until the WAN link is back up, the MPLS dedicated WAN link is back up? All key considerations. Topologies. Does the solution provide a hub and spoke kind of a thing where everything has to go into a central node and back out? Does it provide a mesh where any location can talk directly to any other location? Can you freely mix those topologies in any way that you need to based on your applications? Another key consideration is the form factor. Is it a physical appliance? Is it a virtual appliance? Is it something that you're positioning inside the router on your locations, outside the router on your locations? Does it replace the router on your locations? All of these are options and need to be weighed, benefit versus cost within the context of your own WAN. And lastly, looking forward, SD-WAN is likely to be the first place a lot of organizations get any kind of SDN-like functionality in, and they should be keeping their eye on how it's going to integrate into the rest of their SDN planning, looking out a couple of years when they bring it in at the campus level, when they bring it in their data centers. How is this going to integrate? How is it going to integrate with any cloud management tools that they deploy? So whenever we talk with folks who've deployed SD-WAN solutions, they have all successfully essentially built a business case around the idea that you can get faster and better and cheaper WAN services by deploying a solution like this, that you can get redundant connectivity, you can get higher bandwidth, and you can get greater reliability while spending less money than you are spending now. And while putting less of a burden on the IT staff than you are putting on the IT staff now. So we strongly recommend that your evaluations of SD-WAN solutions be done with the idea of building an explicit business case around getting better and faster and cheaper all at once. It's a very unusual kind of trifecta to get, but every now and then it does happen in IT, so it's a nice thing. And our recommendations are that as you look at your next WAN architecture, that you let TCO and ROI calculations, that you let the need to drive improved performance and security all be a part of driving your new WAN architecture, that you supplement your MPLS WAN with internet connectivity or other forms of connectivity wherever you can in order to get better redundancy, in order to get better throughput, in order to get better service. That you plan on using some kind of SD-WAN solution in order to make that happen, and in order to give you the ability to virtualize your WAN, overlay as many actual WANs as you need on top of the physical WAN underneath, hide the details of the connectivity that make that physical WAN possible, and as much as possible automate the operation of the WAN on a daily basis. We recommend strongly that you try solutions in as many locations as you can before you wind up buying an entire replacement architecture, and that wherever possible you target your trials in high-risk locations, places where you've had service delivery issues in the past, and of course greenfield locations where you can look for a great improvement over your previous experience in deploying to new locations. With that, I will say thank you, and I will hand it back over to Kevin. Thanks.
Thank you, John. That was very informative. Appreciate that. And we do have a couple of questions coming in, but we're going to hold those to the end. So I'll remind everybody out there, if you have any questions, go ahead and type them in the chat window. We will take those at the end. In the meantime, let me turn it over to Neil Abogado from Talari, who's going to talk a little bit about the Talari software-defined WAN.
Thanks, Kevin. At this point, we're going to transition over and discuss what Talari has to offer customers looking to pursue an SD-WAN option. Now, since many of you may not be familiar with Talari, let's start with a brief overview of the company. So Talari has been in business for 8 years, focused on helping customers, primarily enterprises, build better WANs. Our portfolio is relatively mature, with our 4th major software release currently available and our 5th release preparing for launch. We've also made multiple additions to our appliances to scale performance and support a variety of different size branch offices. We have hundreds of customers, most of whom are raving fans of the product. Since we've worked closely with these organizations, which have thousands of locations deployed across 35 countries, we have plenty of time to refine our solution based upon their feedback. This customer experience also enables Talari to bring the tribal knowledge and best practices of deploying an SD-WAN to our prospects and new customers. From a market perspective, we've shown increasing adoption of Talari over the years, resulting in revenues roughly doubling year over year, and 2015 showing continued strong growth. Now that we've introduced Talari, let's chat about what Talari delivers. Talari is focused on what we call a software-defined thinking WAN. At a high level, our solution proactively manages each and every data packet that traverses the WAN based upon predetermined centralized policies and up to the millisecond knowledge of the network. Our solution establishes an overlay network decoupled from the individual wide area network links and hardware components. This allows Talari's solution to take advantage of all available WAN connections while also offering detailed visibility into the entire WAN fabric. The results of this approach include being able to identify problems before they happen and routing data across the best possible connection to deliver unfettered workflow and every application and department to have a very scalable and beneficial infrastructure. What comprises a Talari thinking WAN? Okay, so what we're going to talk about now is how do you build a highly intelligent thinking WAN. Let's take a moment and discuss what the key components are that comprise a Talari solution. First, we have appliances that are physical, virtual, or cloud-based. The hardware ranges from low-end devices that can go into the branch office to data center-capable hardware that supports the aggregation of multiple branch sites and delivers gigabits of performance. Our virtual form factor supports VMware environments, while our cloud option is available on Amazon Web Services. Next, we have adaptive private networking software that runs on top of our appliances and delivers the services and features that our SD-WAN solution is based upon. The key thing to note is that the software is consistent regardless of which type of appliance is deployed. Next, we have Aware, the centralized provisioning, monitoring, and analytics tool which offers a great way to administer an SD-WAN deployment by giving you all the information you need to support full lifecycle management of the WAN. We will cover Aware more fully in a couple of slides. Last, we have an overlay network that links together all of the Talari appliances. This is a full mesh network that leverages a Talari-specific conduit and WAN paths to communicate between the nodes. So now let's take a look at how the Talari SD-WAN is implemented within a traditional network. On this slide, we have a reference model that shows the different layers from applications down to the physical network with the SD-WAN overlay referenced in between. We will start by discussing the implications that the physical network has in deploying a Talari SD-WAN. Now, for most customers, the traditional WAN networking starting point is typically, they will be looking to add additional MPLS capabilities and capacity to accommodate growth or an additional MPLS infrastructure to improve reliability and availability in the WAN. This is in line with some of the comments John made earlier. While increased use of MPLS is a natural route for most customers, as we have just discussed, the high cost associated with continuing to leverage MPLS compared to broadband internet services is an issue. In this case, we find most customers look to deploy a cap and grow approach where incremental growth or redundancy is handled by a low-cost internet infrastructure, and the traditional MPLS network remains intact with all links, both MPLS and internet, active, thus delivering a hybrid WAN. Some customers have gone to an all-internet model where multiple internet connections from different providers are leveraged to deliver a highly robust infrastructure that increases bandwidth, decreases costs, and meets, if not exceeds, application SLAs. Something to note is that all of the deployment options can include wireless technology based upon 4G, LTE, or satellite. These links are typically deployed as a backup to wired connections. From a cloud perspective, the Talari Cloud Appliance is available to create a reliable, aggregated connection to the cloud for SaaS-based applications or other cloud-hosted services. The point that many customers appreciate is the fact that our solution is non-disruptive and works with existing networking, for example, MPLS technologies, and services technologies such as WAN optimization and routing. This allows customers to migrate at their own pace without a rip-and-replace approach required to achieve an SD-WAN solution. When we explore the virtual network, a couple of key services are enabled. In particular, the conduit supplied latency, jitter, and loss information that allows us to support packet-level failover, which improves application availability by detecting a failure within a fraction of a second and moving traffic to the remaining live links without any interruption to an active session. Talari appliances do not require a full failure to initiate a traffic change. Even high levels of latency, packet loss, and jitter will result in Talari proactively steering packets around the problem. Intelligent load balancing spreads a single session across multiple links only when the result will be improved performance. It also adapts to changing conditions and moves packets off links as quality degrades or fails. Packet duplication, which for mission-critical applications helps ensure no information is lost by duplicating and sending packets over all the paths between two sites. If a packet is lost on one link, now it's odds that it will make it through one of the remaining links across the WAN. From a security perspective, we support 128 and 256-bit AES encryption across all of the links, and this is obviously a critical capability for links which traverse over public infrastructures like the internet. From a quality service perspective, QoS is supported to ensure that business policy is preserved during times of congestion. We also make available mechanisms such as TCP termination, packet aggregation, and header compression to help mitigate the amount of traffic that flows over the WAN and improve performance. When it comes to applications, Talari is capable of leveraging application information to ensure proper traffic handling. Applications are broadly categorized as either real-time, interactive, or bulk. Categories impact the default priorities on how traffic is handled. For example, a real-time app that is very latency sensitive will be given priority over a bulk application. Additional granular control is offered through the use of up to 16 classes and rules that can be applied to an individual application. To make it easy to get started, the configuration process begins with defaults that include common applications and associated behaviors. Let's take a moment to discuss Aware, our management and analytics platform. From a configuration perspective, the centralized management capabilities of Aware minimize the administrative effort and operational costs associated with managing a WAN. Rather than configure each site individually and risk errors occurring if the two sides of the link don't match, Aware lets you configure the network as a whole. This speeds up the process of configuration and dramatically reduces the chance for errors. And adding a new site is simple and easy. The configuration interface is also easy to understand and intuitive. It uses the same look and feel as the on-appliance web interface. Thus, it minimizes the learning curve for any of the individuals who may already be familiar with the Talari solution. Now let's chat about Aware's monitoring and analytics capabilities. Aware's monitoring features provide unprecedented visibility into the WAN. Due to the comprehensive nature of Talari's solution, data can be captured by tracking packets in each direction as they traverse the path in the WAN. This provides a very granular and accurate view of the network and application performance. Aware collects the performance data from Talari appliances throughout the network and stores it in a single database. This allows a correlated view of application performance across the network, allowing for comparison of links and application performance between different locations. When network issues occur, they need to be reported and correlated, and Aware is a great and ideal tool to help IT staff do that. Events from throughout the WAN are displayed on graphical maps and tables, plus current and historical reports are available to support fault detection, troubleshooting, network and capacity planning, ROI analysis, and SLA confirmation. Aware supports configurable dashboards that allow each user to customize the display, creating views that fit how they perceive their network. The result is that information important to an organization is always on display, while tooltips and drill downs provide quick access to more detailed information. To wrap things up, we will discuss some of the common goals that you're probably asking your next generation SD-WAN to support and highlight some of the capabilities that Talari has to offer for each goal. In summary, regardless of whether your goals are financial, such as cost reduction, accelerating service delivery times to meet the needs of the business, or managing SLAs to ensure a quality user application experience, Talari can help you achieve all of these targets with a cost-effective, fast-to-deploy, and easy-to-manage SD-WAN solution. With that, let's go back over to Kevin.
Great. Thanks, Neil. That was terrific. Appreciate that. So what we'd like to do now is share a couple of customer use case examples. Talari has hundreds of Raving Fan customers and literally dozens that have come forward and put out case studies. So depending on your situation, we'd be happy to share with you one of these specific examples in a case study. We'd also be happy to put you in touch with a customer to discuss their experience with Talari so you can get a feel for how it operates in the real world. What we have today, though, is just 3 examples I'd like to share at a high level to explain some of the benefits we've been talking about from a specific customer perspective. So one of our customers is Bremer Bank. This is a bank in the Midwest. They've got over 100 locations, and they've been with Talari for over 2.5 years. In this case, Corey Miller, the customer, tells the story that they were really looking for increased capacity to support rich content, video, and streaming applications they were beginning to deploy throughout their branch offices and even to some of the ATMs. So they needed to try and avoid what I call the MPLS treadmill. That is, they already had MPLS in place, and they were very hesitant to purchase more MPLS because it would be very, very expensive. And they did have broadband links standby, and Corey wanted to know, was it possible to leverage those broadband links, those inexpensive internet connections, to bring those to bear within the WAN such that he could maintain the MPLS but also benefit from the broadband. And in fact, they did that, and they were very, very successful. They rolled it out across all of their locations, and they continue to roll out as they add new locations going forward. And they achieved very, very significant increases in capacity without having to increase their MPLS spend by leveraging those broadband connections. So Bremer Bank is one of our very happy customers who had tremendous cost savings. Another example is Maricopa Region 911. This is actually the 911 emergency services for the Arizona areas, particularly around Phoenix and the Phoenix area. Maricopa 911 has 25 locations in Arizona, and they've been active for over 5 years. This is one of our long-term customers that has seen the benefits of Talari over time. Now, in this case, the real focus was about reliability. Certainly, they had cost control concerns, and they wanted to achieve reliability without significantly increasing spending. They didn't want to have dual or triple MPLS. They wanted to have reliability without needing additional MPLS. And in this case, it's literally, in some cases, life and death, because these are call centers where emergencies are being phoned into, and if something were to go wrong in the call center and calls drop or emergency information, they also send maps back and forth and other location information. So the reliability of the network literally translates into life and death situations, and an unreliable network could have really catastrophic consequences. So Maricopa 911 did deploy Talari back over 5 years ago. They're one of our raving fan customers, and it's achieved tremendous reliability. And we do, again, a case study on the website. You'd be welcome to check that out, www.talari.com. It's under resources. But they were able to achieve the reliability. They haven't had any outages of their network since they deployed Talari, even though some of the underlying links can have either failures or have degraded services. The quality of the WAN maintains very, very high consistency, so their voice and their data remains up and running as they need it. And finally, the third example I'd like to share is Equity Office. Equity Office is a real estate firm you're probably familiar with based in Chicago, and they have over 40 remote offices, and they too have been a customer for over 3 years. Now, Equity Offices was an interesting story because they had a situation where they were looking to lower their costs to leverage their hybrid, to leverage hybrid to bring those broadband connections to bear. And they also had an issue of agility. They buy and sell buildings, and one of the challenges they faced is when they bought a new building, they needed to get their WAN up and running. And as John indicated, the wait times for MPLS can be extraordinary. They were experiencing 45 to 60 days and sometimes even longer than 60 days wait to get an MPLS link in. Now, they could buy a building, move in, open up a project office, and be ready to go. And the long pole in the tent in them properly supporting a new building was their network connection because MPLS was taking so long. So what they did is they put Talari in place, and then instead of waiting for MPLS, they linked those new buildings in using broadband connections. And because of the inexpensive nature of broadband, they essentially use two broadband connections. They use a cable modem and a DSL or Metro Ethernet, or as was mentioned, even potentially wireless, 4G. But essentially they created two broadband connections, non-MPLS, that they were able to get up in a matter of days or on the outside weeks. And so a new building was able to be connected relatively instantaneously. And then they placed the order for the MPLS, and 45, 60 days later, the MPLS showed up, and they plugged it in, and then it was also part of the configuration. And what they started noticing over time is that new buildings, during the time before MPLS arrived, while they had Talari and two broadband links, performed completely satisfactorily, and by adding the MPLS, they really weren't getting any net improvement in their performance, yet they were getting the significant added expense of MPLS. So over time, they said, do I really need to continue to use MPLS? And these two broadband connections are working well, and it was really forced by the fact that MPLS wasn't available. So they began experimenting without even telling the users, and they began testing what happens if I turn off MPLS at a given location for a day or even for a longer-term period. So before even discussing with the MPLS provider, they just started an experiment turning off MPLS, and the users didn't even notice it. So they worked it through, and as the next MPLS contract came up, ahead of that they went and made sure they had dual broadband connections to each location, so when the contract was up, they were in a position to not renew the MPLS. So they were able to go straight dual broadband, in some cases triple broadband if they prefer, but they no longer use MPLS. And that's one of the advantages of Talari, is that we embrace MPLS, we support MPLS. Most of our customers want to continue and augment their MPLS with broadband, and we fully support that. But over time, it's up to the enterprise to decide whether they want to continue using MPLS or not. So we allow a graceful transition away from MPLS if the customer so chooses, but we don't require some upfront cutover away from MPLS. We embrace it and then we extend it, and Equity Office is one of those case studies that's really a good example. And frankly, there are many, many other Talari customers just like Equity Office that take a similar approach of embracing MPLS and augmenting it in a hybrid and then ultimately traditional, and then ultimately transitioning to a straight, full broadband with no MPLS. So those are 3 case studies. I mentioned we've got lots and lots more we'd love to share, but in the interest of time, we just wanted to share kind of 3 examples to give you a flavor. Before we get into the Q&A, I also want to mention where we do have additional resources. At our website, www.talari.com, there's a resources tab at the top. That is where you'll find more of these case studies. You'll also find some more information you might find interesting. Packet Pushers is a very influential podcast technology evangelist, and we've done 2 different podcasts with them. They're audio only, but if you want to download it, if you've got some free time, you might find it interesting. The most recent that we did just last month was with 4 of our customers who went online with gentlemen who run the podcast, as well as John Dickey, our CTO, and they shared over the course of an hour various deployment scenarios, what they thought they were getting before they deployed Talari, what they actually got, what surprises they had, and what experiences. And they give some tips and tricks in terms of other people that are considering deploying SD-WAN. So I think you'll find that very, very useful. In addition, there's another Packet Pushers podcast that we did about 4 or 5 months ago. That was John Dickey, our CTO, and it's a pretty technical deep dive, an hour-long deep dive where the Packet Pushers hosts asked John some very penetrating, deep technical questions. So it's a deep dive for those of you that are looking for more technical information. Also on the website is one of our customers, Benevis. It's an ROI analysis that they initiated based on the cost savings that they experienced, and it really is very, very helpful. We think you'll find it interesting to learn a very specific and very detailed case study on cost savings. So with that, we will open it up to question and answer. Again, feel free to type the questions into the chat window. I see we do have several questions here, and so let me start off and kind of feed them out. First of all, the first question here comes, and I think it's John, it's directed to you. We've got a number of questions about MPLS, no surprise. But one of the questions says, do you believe that the global MPLS market will significantly decline in revenues or the number of connections in the next 5 years, unlike what other analysts are forecasting? So, John, I think that's getting to you in terms of how you see the MPLS market rolling out over the next 5 years.
If we're speaking globally, I would say no. We should expect to continue to see some growth in both revenues and the number of connections. If we're speaking just within the United States, I would not feel the same way. I would expect to see things level off or even begin to decline.
Good. And John, a follow-up question here from someone else is saying, do people really give up MPLS, and how has the experience been? We, Talari, are talking about it. From your perspective, are you seeing many customers that are really biting the bullet and transitioning from MPLS, and how are they reporting their experience?
We have not had clients give up their MPLS networks completely yet, no. We have had people that we've spoken to in research do so. Their experiences so far have been positive. None of them dropped their MPLS network without getting very comfortable with the level of service they were getting from the broadband providers that they were making use of, or whatever alternate connectivity method they were using. So nobody just said, hey, I'm just going to do some kind of snap transition, and I'll put this in and I'll pull the MPLS out right away after. It's typically not a super long process of getting comfortable, but definitely a process of getting comfortable with the providers that you're replacing MPLS with and with the level of service that they can provide.
Yeah, that's pretty consistent with what we've seen here at Talari, for what it's worth. As I mentioned earlier, we don't see many customers who are saying, on day one, I'm going to rip out MPLS and replace it with Talari and dual broadband. We do see more of that kind of cap and grow strategy. People saying, I got my MPLS set up, I'm dependent on it, it's working, but I've got capacity challenges. My MPLS occasionally goes bad. I need to supplement it. I need reliability. They don't want disaster recovery. They want business continuity. And so they're looking to bring the broadband that they have, often case deployed right beside the MPLS, but in some sort of a backup mode. Without an SD-WAN, that backup is rarely graceful. If you get an outage on the MPLS, or as John mentioned, high latency or high packet loss, it's rarely a graceful event. It maybe takes, whether it's seconds, minutes, or hours. The recovery, does take time, and it's service impacting. So customers do seem to like to keep MPLS in place and run hybrid along with it. But as I mentioned, it is interesting, and maybe Talari has a more forward-viewing seat here because we've, over so many years, had so many customers running hybrid. We have given those customers the chance to experience multi-threaded SD-WAN, and we are experiencing numerous customers that are decommissioning MPLS eventually, but only after having built up confidence in a hybrid mode. So I can tell you we do have multiple customers like Equity Office that have transitioned off of MPLS, but very few that want to do it immediately right up front.
Let me just dive in with an addendum. We have had folks, though, say they stopped putting out new MPLS connections. So when they were adding locations, they were no longer provisioning MPLS to them.
Good. Yep, that makes sense. So one more question here around kind of cost savings. There's a question specifically, how much can I expect to save? And let me answer that one. I'm not sure, maybe Neil, you might want to come in behind, but it very much is dependent on the customer situation. So the savings is very much dependent on exactly what you're spending today, and also what you're looking for and what you're trying to achieve. I do know that Talari, on that same resource page that I mentioned, www.talari.com, we do have a savings calculator, and it's just meant for one location. You can go in there and plug in how much bandwidth you have today, with your MPLS, and how much you pay for it. Also, how much broadband you have standby, and how much you pay for that. And then finally, how much increased bandwidth you're looking to achieve. So there are 5 simple inputs, and it's a dynamic calculator that as you change those inputs, the charts and graphs will change with you, and it will show you specifically how much you're paying today, how much you'll be paying if you try and solve that problem with additional MPLS, and then the fourth bar chart is how much you would be paying if you solve it keeping your existing MPLS and your existing broadband. And then the fourth is if you go to straight broadband. So it does very dynamically show both how much cost will be incurred depending on which approach you take, as well as how much bandwidth available you have depending on which one you take. So we invite you to go to the website, check out the calculator. It's for a single location. You can also download a report, and we'll email you a PDF that includes your own specific savings as well as some other information about Talari that you'll probably find pretty useful. Let's see, one more question here, another one that looks like maybe, Neil, this is best for you. It says, how does SD-WAN interact with existing technology like WAN-off and firewalls?
Basically, we're pretty much transparent. We work in conjunction with those technologies currently. And so, let's say you have your router in there, they go and they support their functions. Same thing with WAN-off. The compression, any caching, any of the other techniques that product and that solution delivers, you keep those. And they remain running in the network. Now, in some cases, we can support and augment and maybe offload those functions. But in many cases, we find customers are maintaining those devices, and they drop Talari in behind that infrastructure. And we offer our services then basically in conjunction with those devices. That's a very common deployment model. So you keep your router, you keep your WAN-off device, let them kind of continue working their magic. And this is a part of our non-intrusive deployment model where, you keep that infrastructure that you usually have for many years, and then you insert us in and we start building our overlay in conjunction with those devices being in place. And then over time, some of the functions we may have available that will mitigate the need to have all those devices. But typically, what we see today is that most customers just deploy us alongside of the existing technologies.
Excellent, thanks. I see a couple more questions coming in here. Here's one. Steve asked, how does Talari work with voice traffic across WAN circuits? And you won't be surprised that the vast majority, if not 100% of our customers who deploy a software-defined WAN are running voice, mostly VoIP, across those circuits. And frankly, that's one of the use cases that most benefits because we're very sensitive to latency and packet loss. And so as Neil mentioned, we can, in less than a second, if we notice high latency, we can switch to the different line and therefore be on the best connection at any given time. And the other thing about it is that with certain applications like voice and things like VDI that are relatively low bandwidth but very latency sensitive, very packet loss sensitive, a standard deployment mode that Talari can support is duplicating the packets on the send side, transmitting them across both links, and on the receive side, the first arriver gets used and the late arriver gets discarded. So it's sort of like belt and suspenders. Unless the same packet is lost on both circuits, you essentially get to zero packet loss. And because the packets are individually racing across the various paths, with the first arriver getting used, by definition, you get the lowest possible latency at any given instant. So voice is one of those applications, real-time voice, one of those applications where Talari really sets itself apart from competitors because we provide very, very strong support for real-time applications.
That actually jibes well with what we've been hearing on our client side. People are getting interested in SD-WAN technologies because they're having trouble deploying UC in whatever form, voice, video, combo, to some of their branch offices, to too many of their branch offices.
Yep, excellent. So I see we're towards the end of time here. One last question I see that we can squeeze in is, what is the largest number of sites you currently support? Does Talari scale? And the answer is that we do scale quite large. We have customers today that have deployed multiple hundreds of sites on a single Talari image. So we can today go up to 256, and releases coming out early next year. We can go up to 500 locations on a single image of Talari. And if you have more than 500 locations, then we can deploy multiple instances of Talari and really scale unlimited. But scaling is not a problem. And again, we think we set ourselves apart from our competitors in that we have numerous large deployments today that are supported. And the last question here is, how has Talari set themselves apart from the competition? I really think it has a lot to do with the fact that we've been in the market for 5 years. We've got many, many customers, and not just to brag about it, but as Neil mentioned, we're now about to release 5.0, and so we've refined and improved the product based on real-world customer experiences, and our support team has sort of seen every possible scenario, and we've learned many lessons over the years. And so we have very, very happy customers, and many of them are at large scale. So I do see we are at the top of the hour, so thanks for everybody participating. We greatly appreciate it. And we look forward to talking to you. So please do go to www.talari.com, sign up for a demo, and let us know. We'll be happy to come out and talk to you about your specific situation. So thanks again for all of you participants, and have a great day.